Okay, so for lesson 4.6, we are graphing. You're going to be fitting a line to data. A lot of times when you do research, when you do a graph, you have a bunch of points, and they use a line that can kind of correlate to all the points. It goes through the middle to give you a general idea of the correlation. So let me take a picture of this. All right, so let's look at this together. A scatter plot is a graph used to determine whether there's a relationship between paired data, and you can find the trend in the data. If you look at this one, all of the points, where's my little marker, are relatively close to that line going in a positive slope. These points are located relative to a slope that's going negative. This is the one that's the hardest to determine, because when they're that spread out, it's a no correlation, because you can't really see a line that goes positive or negative. That's basically what we're going to be doing today. A lot of what you're going to do is graph all these little, and then draw a line through it to find the line that's, and when you do that, you just pick 2 points and draw a line. So let me erase and I'll show you. So you see here, this line that's going through here, it's relatively going through that dot and that dot. So I would have just picked those 2 dots and connected them. Man, I can't talk today. Same here, it's going through this dot. I would have just done something like this. Okay, so that's how you're going to graph these. Let's look at example 1. Okay, so we have an A and B here. And the instructions are, describe the correlation of the data graphed in the scatter plot. What? Oh. So looking at A, if you were to look at this grouping of data points, what slope do you have here? Positive. It's a positive slope. So when they ask you to describe the correlation, you're going to look at whether it's positive or negative, and then you're going to talk about the labels. So in this case, the more hours they spent studying, what happened?
Test scores good.
The higher the test score they got. So the way to write this, read with me on page 264. The scatter plot shows a positive correlation between the hours of studying and test scores. That means as their hours of studying increase, the test scores tended to increase. So, and you can put that in your own words whenever you have to do this for the assignment. Okay? So now let's look at B. What slope is that one? Negative. And we're talking about test scores and what? So the more television they watched, the lower their test scores tended to be. Okay? Any questions on how you would tell me the correlation of these? I'll write the second one. So the more television they watched, the lower test scores they received.
What's correlation?
Correlation, how do I explain correlation? It's when things are near each other, similar to each other. Does that help? You want me to look up the actual definition? Okay. Good? Everybody got this? All right, let's look at example 2. The table shows the length in centimeters and swimming speeds in centimeters of 6 different fish. For A, they want you to make a scatter plot of the data, and B, describe the correlation. So you need to go get a graph. Go get a graph.
Yes, so good.
I'm actually going to make a graph, not put that one, because most of all of the data is in so you really only need the quadrant 1 because all of the data is positive. So I'm going to go by tens. Going across, and then going up, okay, and then going across. This was what? Length, and going up was speed. And it is very important you label. Okay, so the pike fish is 37.8 feet long. So just under 40. And how fast did it swim?
148.
Okay, so almost to 150. So he's about there. The red gurnard is almost 20. And going 47, so he's right there. The black bass is 21.3 and 88. So up here, 26.2 and 131. And 26.8 and 98. All right. So now you've seen that I've graphed this. How would you describe the correlation here?
The smaller it is, like the less speed.
Okay. So this would be considered a positive correlation.
Yeah.
So as I went this way on the chart, meaning they get longer, then we go faster. So you would say the longer fish tend to swim faster. You could say positive correlation. Positive, I don't know if I'd say, yeah, positive correlation. Good. Any questions on how we did that? And when you're making these graphs on the scatter plot, I'm sure your plots, your points are just slightly different than mine. I don't go, well, that's 22.6, not 22.1. If you're within the general area and I can see that you have the positive correlation, you're good. So don't be super stressed about being extra accurate right here. On here, when you draw this line that kind of goes between these lines, do you know what that line is called? It was one of your vocab words. Called the line of fit, exactly. you're drawing a line that can most approximately model the data. So just remember that vocab word. Line of fit. All right, so now let's look at example 3. We're going to learn about making a equation when you're dealing with this kind of stuff. All right, so this is example 3 for your journals. So the table shows the number of active red cockaded woodpecker clusters in part of the DeSoto National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years since 1990. So that when they tell you that, that means the clusters is on the Y line and the years is on the X line. So when you're doing your graphing. So draw your line. Okay, and then looking at the years, it's years since 1990. They go up by 1, so I'm just going to make this. And then our data goes, it's in the 20s to the 50. If you do a little squiggle like this, it's a little break, and then you can start at 20 instead of doing 0 to 20, which is useless for this. All right, so now let's graph this stuff. So 1992, that's going to be where this 2 is. And they're at about 22. So 1993, 24. 1994 is 27. 1995 is 27. 1996 is 34, so we go up a little. 1997 is 40. 1998. 42, 99 is 45, and 2000 was at 51. So looking at my graph, I can already tell what slope I have. What kind of correlation do I have going on here? Positive correlation. To create an equation, all you have to do is pick 2 points out of this correlation. So for instance, I would pick, well, it doesn't really matter which 2. So you could pick that first one and this one, it doesn't matter. I'm going to pick the last one because then the math is easy. When you're looking at the graph, you could just say, well, I want to pick this one and use those points. But if you want to draw a line between them, then this one lines up with this one. It really doesn't matter. I'm going to be able to look at your lines and go, okay, they're within the right decimal, you're within a decimal point or 2 of what the answer is. So how do we find slope?
Y2.
Very good. Y2 minus Y1 over X2 minus X1. So picking the 2 slopes I did, I would say 2000. Well, that's the X, I'm sorry. So we need to do Y first. So I would say 51 minus 22 on top for my Y's. And then the X, now this is in years, but remember we put them as tens. So I would do 10 minus 2 on the bottom. Because the 2 stands for 1992, which is just 2 on our scale. Does that make sense? None of you were looking up here when I said that. Okay, so this bottom row is years, and 0 stands for 1990. So 1 is 1991, 1992 is considered 2. So I chose the point 1992, but on here it's 2. And I chose the point 2000, on here it's 10. So for my math, I'm doing 10 minus 2 on the bottom. Not doing 2000 minus 1992. Either way, you're going to get 8, so it's not a big deal, but I just wanted you to see that. So what's 51 minus 22?
29.
Okay, so that's my slope, 29 over 8. If you can reduce it, do so. If you can't, you just leave it as a fraction. And then I grab one of my points, and I'm going to use this one's 10 over 51. Well, the point would be 51 comma 10. And I plug that in so I can find my y-intercept. Yeah, hold on.
How'd you get 10?
Same thing here. Yeah. The year is x. Okay, so I flipped it. That's what I was checking. Year's x, and then the slope is y. So I'm going to say 51 equals this weird fraction, 29 over 8 times 10 plus b. And you're going to get a decimal, and that's fine. So what's 29 over 8 times 10? Yep, so then I have 51 equals 36.25 plus b. So then I minus that 36.25 over to the other side. So then 51 minus, say it again? So then b equals negative 14, oh, positive, sorry, 0.75. So then you just rewrite your equation at the very end. I'm going to turn the page here. Let's look at, one other thing. So I'd say y equals 29 over 8x plus 14.75. And there's my slope. Okay, so when you're trying to write the slope of a line, when you're using correlated data, you just pick 2 of the points. It doesn't really matter. I wouldn't pick them right next to each other. Try and pick them kind of near the ends of the line. Any questions on how to make a slope or how to make a line? Okay, that's it. So you're doing lesson 4.6, just 3 through 21 odds. So,